Hey friends, today's our last day of week 7. It's day 4, and I thought it'd be helpful to walk you through these word problems in the Let's Try section. Before we can jump into that, we need to review tape diagram and arrow way because those are the two concepts that come up over and over. So if you're with me yesterday, when I say yesterday, I mean Monday, the tape diagram is focused on part, whole. So we looked at this one on Monday. And we're realizing that we see this kind of terminology with number bonds and with just regular addition or subtraction equations. So if you know one part is 2 and the other is 8, we know those two numbers together will add up to get us our whole of 10. And you can see that in the equation as well. We know that fact families often work the other way, where 10 minus 2 would give you 8, and 10 minus 8 would give you 2. Looks the same or very similar in a tape diagram, where the whole is on the top as 10, and then you have one part you know, and you're always looking for the other part. You can either do think addition, something plus 8 equals 10, or subtraction, 10 minus 8 equals something, which we know is 2. Arrow way is actually quite similar, though it looks different. So let's explore. If I'm looking at the problem 37 plus 63 equals something, I of course can jump right in and do this in vertical form. And if you're in my class, we talk about it all the time. Is that the most efficient way? Is that the best way to solve? Sometimes yes, and sometimes no. In this case, I'm looking at the ones place here and the ones place here, and I see a snap fact, a fast fact. 7 plus 3, I know, is 10. So if 37 plus 3 is going to get me to my next benchmark number. So in your arrows, you start with that 37, and you're going to add 3 to it to quickly get to your benchmark 40. Fantastic. Then it becomes really easy. You only have 60 left. So you'll add 40 plus 60 to get your answer of 100. I chose the number 100 because you're going to see dollars used in this lesson, and a dollar is 100 cents. So it makes sense to use it that way. That's almost like a homophone from what Miss Weber is teaching you. Cents and cents, spelled differently but sounds the same. All right. So now that you have the tape diagram and arrow way down pat, you're going to get your DCPS packet and go into the Let's Try section. I'm going to solve those first two problems with you before I send you off for your problem set. So, the first question. The notepad Elsie wants costs $1. She has 4 dimes and 3 nickels. How much more money does she need to buy the notepad? The first order of business is to draw the coins that she already has, the part we know. So, I have 4 circles here. Just like we did at school, you're going to label them for what they're worth. So they are a dime. We know dimes are worth 10 cents. I'm going to label them with the D to show that they are dimes worth 10 cents. Next, she has 3 nickels, so I'm going to head and draw the same 3 circles, and I'm going to put an N in there instead for nickel. Nickels are worth 5 cents. So now that we see what she has, our job is to find the total value of the coins kind of in her pocket right now. So go ahead and on the line tell me how much 4 dimes is equivalent to. What is the total value of 4 dimes? And then on the line below, what is the total value of 3 nickels? If you counted by tens correctly, 4 dimes is 10, 20, 30, 40 cents. And 3 nickels is 5, 10, 15 cents. That allows us to do quick math for her total value. 40 plus 15 is 55 cents. Now, this is where the arrow way comes in. They want us to think addition before we do subtraction. So 55 plus what will get us to 100? So you'll start here with your 55, the total value of the coins. Now, you want to get to a benchmark number or something easy to work with. I want to get as close to 100 as possible at this point in the year. It's easy to make that big jump. So I'm thinking 55 plus what? Well, I know that 5 plus 4 is 9. So I'm thinking if I add 40, I'll get something in the 90s. So I'm going to go ahead and add 40. 55 plus 40, gets me pretty darn close to 95 cents. All right, now it's quite easy. All I need is 5 cents more to get to my 100 cents or $1. Now, remember, they're asking us how much more money does she need? The money she needs is above. 55 is what she has. Here's how much more we need to add to our 55 to get her what she needs for the notepad, the $1. You can see it in subtraction below. If you did $1 minus what she has, whole minus part, and you'll get the missing part, the 45 cents. You can hit pause, rewind, rewatch this to see how I did it. I'm going to move on to question number 2. If you're ready, move with me. If not, pause and take the time you need to finish this up. Number 2. Daniel had exactly $1 in change. He lost 6 dimes and 3 pennies. What coins might he have left? So I'm looking. I can either draw the coins on the left side or I can start with the tape diagram. When I look at this word problem, I'm already noticing one whole and one part that they've listed out for me. Do you guys see where the whole is, the biggest number? If you said the first sentence, you're right. He had exactly $1 in change. He lost something and he has coins left. We know those numbers are going to be less than $1 or 100 cents. So I'm going to start in the tape diagram by putting my $1 as the whole. Easy enough to work with. Now there's a part we know. It's our very second sentence. He lost 6 dimes and 3 pennies. Well, we have to think, how much is 6 dimes and 3 pennies? Let's count them up. 10, 20, 30, 40, 50, 60. Switch. 61, 62, 63. The part we know is 63 cents. All right, so far so good and so quick. So now what we're looking for is the part we don't know. What coins might he have left? This is where our answers could be different from one another. You can follow along with me or try on your own. Your choice what you want to do at this point. We're looking for this missing part. So we're going to set it up to find 100 cents or $1 minus 63 cents gives us something. Or something plus 63 equals $1. So, what coins might he have? Let's see. I'm going to start by adding on 10 at a time. I'm going to count on and think addition. 63 plus something is going to give me that 100 or that $1. So 63 plus 1 dime he might have. 73. I can fit another one. 83. Can I add another dime or will that take me over $1? Oh yeah, I can add another one. 93 cents. Can I add another dime? What would happen if I did 93 plus 10? Would that take me over $1? Yeah, definitely. My tens would be 10 tens and 3 ones. Nope, that would take me over. So I'm going to stop there for my dimes. So I have 63, 73, 83, 93. What's the next coin that I can add? It's got to be less than 10. Oh yeah, a nickel. 93 plus 5 cents more would get me to 98 cents. Oh wow, we're getting really close. I'm going to have to switch again though because I can't add 5 more. So I'm at 98 cents. What'd you say at home? Did you say add 2 more pennies? If you did, thanks so much. That would take me to my 100 cents. These might be the coins he has. If you came up with something different, that's okay too. You can shout it at the screen. What did you come up with that might be different than mine? I heard somebody say 1 quarter, 1 dime, and 2 pennies. That's possible too. So now we need to figure out how much are these coins worth? Count them up. 10, 20, 30, 35, 36, 37. If your coins total 37 cents, then you are absolutely correct. The missing part, the coins he could have left in his pocket, are the ones I'm showing you at the left or the ones you might have drawn at home. Whatever they are, they should equal 37 cents. I hope that this was helpful to walk you through the let's try. Now you're going to move on to the problem set to try on your own using either tape diagram or Arrowway. All you need to remember is that tape diagram and Arrowway are all about making a simpler problem for yourself in the way that works for your brain. Not mine, not your brother, not your sister, your brain. What works best for you? Find that strategy and try it on.